Welcome to this video on factoring quadratic trinomials. By the end of this video, you should be able to rewrite a quadratic trinomial in factored form. So as a review, let's take a look at problem 1. When we start to factor our trinomials, we always want to take a times c, which in this case is negative 20, and we want to find all the factor pairs that multiply to 20. So that would be 1 times 20, 2 times 10, and 4 times 5. Because I multiplied and got a negative 20, that means one of my factor pairs is positive and one of my factor pairs is negative. I don't know which one it is, but I need to look. I need to make my factor pairs add to negative 1. They multiplied to negative 20. Now I need them to add to negative 1. And the only pair that would give that to me is this pair right here, if I made the 5 negative and the 4 positive, because 4 minus 5 is negative 1. So we're going to substitute this in. So we're going to say 10m squared plus 4m minus 5m minus 2. Once we have 4 terms, that's when we can split it down the middle and deal with 2 terms at a time. On the left-hand side, when I look at my 2 terms, a 2 is the biggest number that divides into each of these evenly, and they both share a single m. So my GCF is 2m, and when I divide that out, 10 divided by 2 is 5. One of the m's cancel, leaving 1 behind, and 4 divided by 2 is a positive 2, and the m's cancel, so I am done on the left. On the right, when I go look to see what they have in common, I notice that my leading coefficient is negative. That means whatever I divide by is going to have to be a negative number. 5 and 2 do not have any numbers that divide evenly into each, so we can take out a 1. And there's no letters and no variables in common. So minus 1, negative 5 divided by negative 1 is positive 5, and the m comes along because it has nothing to divide by. Negative 2 divided by negative 1 becomes positive 2. We know we're correct when we look and we see that our parentheses are identical. That's our GCF we're going to pull out, 5m plus 2. And what's left over is 2m minus 1 will go in the other parenthesis. Okay, but sometimes before we even begin to factor, there's a GCF that has to come out before we even multiply a times c. So let's take a look at number 2. When I look at number 2, first I notice this isn't a quadratic because it goes to the third. So when I look again, I notice all of the terms have an x. So they're sharing something in common before we begin. We need to pull out a GCF. So I also looked at the numbers, and I know 3 will go into 3, and I also know that 3 goes into 18. So I have a GCF that I need to pull out before I even begin this problem of 3x. When I divide out the 3x, I am left with x squared plus x minus 6. Right. What we need to factor, like we did over here on the other side, is just what's inside the parentheses. This 3x is a GCF. We will not need it again until the answer, so I'm going to take it and I'm going to put it down here where I'm going to write my answer, so I don't forget about it. Okay, so just like before, take a times c. So 1 times negative 6 gives us negative 6. Because it multiplied to a negative number in my factor pairs, I know one is positive and one is negative. The only way to get 6 is 1 times 6 or 2 times 3. And I need to add to a positive 1. So if I have a positive 3 and a negative 2, that will add to negative 1 to positive 1. So that's my factor pair. X squared minus 2x plus 3x minus 6. So from here it's exactly the same. I'm going to split just like I've been doing because 4 is too many to deal with. I notice that these 2 terms have an x in common. So my GCF is x, and I'm left with x minus 2 once I divide those out. 3 and 6 have a positive 3 in common. When I divide a positive 3 out of this binomial, I'm left with x minus 2. We know we're right because our parentheses are going to match. So one parenthesis will be x minus 2, and what's left over for the other parenthesis is x plus 3. But this 3x has to be part of the answer because we have to be able to multiply this whole thing back together and end up where we started. So if we don't include this in our answer, we will not have the same result when we multiply. Let's try it again. 18x squared plus 3x minus 36. They don't all have x's, so I know I'm not going to take out an x here, but I do notice they all share a 3 in common. So I need to take that GCF out before I begin. So I'm going to take out the 3, and what will be left behind is 18 divided by 3 is 6, and then we have our x squared. That didn't simplify. 3 divided by 3 cancels to 1, which leaves just the x. And then negative 36 divided by 3 is negative 12. Okay, so what we're going to do here is we are going to follow from this the exact process that we've been doing. I'm going to take this GCF and I'm going to put it all the way down to where I'm going to write my answer so I don't forget it. So now I have 6 times negative 12, which gives me a negative 72. Because that number is negative, I know one of my factors will be positive and one of my factors will be negative. So all of my factor pairs, so I can kind of look at them, is 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. So those are all my pairs. If you're starting to get to where you can see the pairs, you don't have to list them out, but this is just an organizational tool to help us. We're trying to get a pair to add to positive 1. Well, there's only one pair that's 1 apart. That's this pair. They have opposite signs. To get positive 1, I'm going to have a positive 9 and a negative 8. So I'm going to substitute those in. So we're going to have 6x squared minus 8x plus 9x minus 12. We've made our 4 terms, so we're going to split right there. On the left, 6x and 8x share a 2, and they also share a single x. So on the left, the GCF is 2x. 6x squared divided by 2x leaves 3x. Negative 8x divided by 2x leaves a negative 4 because those x's will cancel to 1. Right? On the right, 9 and 12 share a 3, and it is a positive 3 because this says plus 3. So I'm going to say plus 3 down here, and what will be left over is 3x minus 4. Here's our chance to check. Our parentheses are identical, so we know the GCF of 3x minus 4, and in the other parenthesis will be 2x plus 3. So again, if we were to multiply all of this back together, we have to end up with the exact thing that we started with. We're not changing the value, we're just changing the form it's written in. All right, so let's take a look at number 4. They don't all have a variable, so I don't have to worry about taking out a variable, but 6, 28, and 32, I think the only number that goes into all 3 of them, the biggest number that will go into all 3 of them evenly is 2. So here's how we can check. Let's take out a 2 and see what happens. 6a squared divided by 2 will give us 3a squared minus 14a plus 16. So here's how we're going to check. When I look, 3, 14, and 16 have no factors in common. There's nothing that goes into that multiplies to 3 that also multiplies to 14. So I know I'm right. If I was here and I still had numbers that I could pull out, I didn't take out a big enough GCF. So this GCF, I'm going to bring them all the way to the bottom where I'm going to write my answer. I'm going to take 3 times 16, which gives me a positive 48. Now, to have two numbers multiply and give me a positive number means they're either both positive or they were both negative. We don't know. We don't see the factor pairs yet. We don't know what's happening. But I know that they're going to have to add to this negative 14, which means my pair they're both going to have to be negative. So I have 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. Those are all my factor pairs that will give me 48. I need two of them that add to negative 14, and they have to both be negative. So if these are both negatives, which pair will work? Will be this pair right here. Negative 6 minus 8 more is negative 14. So we're going to substitute those in. 3a squared minus 6a minus 8a plus 16. We're going to split it right down the center. So let's take a look on the left. They have a 3 in common because 3 goes into itself, and 6. And they share a single a. So the GCF on the left is 3a, and I'll be left with a minus 2 when I divide that out. On the right, they share an 8, but it's going to have to be a negative 8 because the leading coefficient on the left, on the right is negative. So I'm going to say minus 8. And I am left, those cancel to a positive 1, leaving a minus 2. Our parentheses are identical. So one is a minus 2. When we take out that GCF, what's left behind is 3a minus 8, including the GCF from the original problem. All right, let's have you pause this video and see if you can find the GCF and write this in the first factored form. So just to this form right here, and then come back once you have finished. All right, so that you should have gotten to this point. Now let's see, we're going to start, once we have our GCF, we want it to come down to the answer. So we're going to put our final answer down here. We need to take a times c, which gives us a positive 18. Positive number through multiplication means we either had two positive numbers or two negative numbers. So I have to look right here. I need to get them to add to a positive 9. That means my factor pair will be a positive positive. So what I want you to do is pause the video, find your factor pairs, figure out the correct center, work it all the way out and come to your final answer, and let's see how you do. Here we have it all worked out. You can pause the video to check to see how you did. If you got something wrong, you can figure out what your mistake was. If you do not have the 2 here, you're not counted as correct. So make sure you've brought that GCF all the way down. For our final problem, I want you to try the whole thing on your own, start to finish. Come back once you finish to check your work. Here is our final problem. You can pause the video to check your work if you got a different answer to see where you might have had a mistake. Make sure you've got your GCF from the original in the example. Now remember, if you wrote x plus 1 and then 2x minus 1, if you swap the order of the parentheses, that's okay. The order of the parentheses does not matter. What's inside the parentheses has to be the same order. It has to be 2x minus 1, and it has to be x minus 1. Hopefully that was helpful. Let me know if you have any questions. See you in class.